All right, guys, good evening to everyone. How are you all doing? Hope you had a great Sunday. Um, we're about to start, and I'll just share my screen and then we start. So once again, you're welcome to the data science hands-on training. So this data science hands-on training is there to equip you with data science skills to help you become valuable in the world of data. So as you know that the world now is the world of data, artificial intelligence, machine learning, and all this cool tech. But you need to gain the foundation in order to excel in this field. And the goal of this training is to give you the needed foundation, is to give you the needed background that you need, in order to excel in this field. So yesterday something happened. We did talk about something yesterday, and unfortunately, we were recording, but the recording wasn't saved very well. So we encountered errors when compiling the recording. So we lost the recording basically. So what I'm going to do this today is that I'm going to do a little recap of yesterday's class in order for us to have it in the recording, and then I'll then move on to what we are supposed to study for today. Um, just like we said before, this is an introductory class. So it means that the class is aimed for those without background in machine learning or without background in data science that want to get into the field. So it's just like the first class that gives you the first, walkthrough on how to gain understanding about the field. So it therefore means that we are not going so much in-depth details about things. We are trying as much as possible to teach you the details, to teach you the concept in simple ways. We don't want to bore you with so much at the same time. We want to ensure that you have the simple things, the basics covered, and we give you the skills that you need to build yourself in the area. Now, most of data scientists we know are self-taught in the sense that they drive their own learning. So what we are trying to do here is to put you on the path where you can now drive your own learning. And the fellow tutors here are Augustine Okoli and Oluwaseun Adeyemi. So they did teach you last week. In the last week class, they looked at several concepts, uh, one being an overview of data science roles. So they did cover that last week. They covered an overview of data science roles last week. And they also looked at what is the industry importance of data science. So in last week class also, you guys covered Python for data science. You looked at the basic syntax, data types, how to write functions in Python, how to manipulate using NumPy and pandas. You looked at all that last week. So that was good. And so for this class this week, we are looking at data science methodology, because you need to know the methodology you need to apply in doing data science. We're looking at data cleaning and preprocessing, exploratory data analysis, and data visualization using Matplotlib and Seaborn. All right. That's our content for this week. So just like I told you, I did give you a detailed explanation of this yesterday in our yesterday's class. I went in detail, but unfortunately we lost the recording, and I just want to do a recap. So I will not be in much detail as I was yesterday, but it's just a recap and in a way to remind us of what we learned yesterday, and then we can proceed with today's class. So I did say yesterday that data science, it is good to do it with a methodology, because if you're just doing data science and you do not have a methodology, you may encounter issues. You may come to a solution, but you may not know if that solution is your optimal solution. And I told you that your result is as good as the method or the process by which you used in getting to that result. So if you applied a good process, a good methodology, a robust methodology in getting to a solution, more or less that solution is reliable. But if you apply a methodology that is not robust, a methodology that is mediocre, you most likely would have a mediocre result. So our goal here is to apply a standard methodology. And CRIPS DM, as I said, is cross-industry standard process for data mining. So this is a process that you can apply in any data science project, and more or less you would know that you've covered all the things that needs to be covered. So it is widely used in conducting data science projects, both in industry and in academia. This methodology is widely used. So it provides you with a structured approach, that guides you through the data science process. So it gives you a structured approach. And we said the importance of having a structured approach is that it helps you not miss any important detail. You do not miss any important detail when you're following a structured approach. But mostly when you're just following anything that comes to your mind, you more or less would miss an important step. Say, for example, you may do your data science project and you may forget to scale your features. And if you forget to scale your features, depending on the model you're using, it may have an adverse effect, you see. So this is why it is good to follow a structured process so that you know that you've done the due diligence and you've done what you're supposed to do. Hence, the result you're getting is the best result for that problem, okay? So we also said that importance of following a systematic approach. I just discussed that now. And we also said yesterday that the data science methodology is an iterative process. Iterative here is in the sense that you don't start with one and just go to the next and then go to the next and go to the next and go to the next and then get to the final solution. It is not linear in that sense. It's iterative in the sense that you can start with business understanding and then go to data understanding, and you may have a need to go back to business understanding. You understand? Before you go to data preparation. And when you're in data preparation, you're preparing your data, you may have a need to go back to data understanding. So you see, it's an iterative process. And you may then finish all this process, get to evaluation. And after evaluating your model, you observe that your model is not performing as you want it to perform. Hence, you may then go back to data engineering, or you may go back to business understanding, or you may go back to data understanding. So these processes are iterative. And I did explain here that in business understanding, what we are trying to do is that we are trying to determine the business objective. What is the objective of the business? And I told you that business in this sense is a loose word we are using. So business does not mean that it must be, it doesn't mean that all data science project must have a financial incentive. Okay, you can even do data science for a non-governmental organization. You can do data science for sustainable development projects that you're not trying to gain, from it. So it doesn't mean that it must be a business that brings profit. We just use the word loosely. You can even be for a religious organization. It can be for a sporting organization. It can be for whatever. But the emphasis there is that you need to understand the objective of that project, or the objective of that business, or the objective of the field where you're applying this to. You need to understand that. You also need to assess the situation. You need to know, what am I dealing with here? You need to determine the data mining goals. What are the goals of the project? So if you're working for, I gave you the example yesterday, that if you're working for an insurance company and you're dealing with default, the word default in an insurance company is not the same word as default in computer science or in engineering, where you mean default to be the status quo, or you mean to be the normal settings of a particular application. That's not what it means. In insurance, default means to not pay a loan. So to default on it. So you need to understand what these jargons are in your field that you're working with. And those jargons will be reflected in the data set, right? They'll be reflected in the futures. So you need to understand what those jargons mean. And therefore, you need to understand the data mining goals. You also need to produce a project plan. So when you're doing that, you need to produce a project plan. This project plan would help you when you're solving your data science. So you need to come up with a project plan. It's very important. It's going to help you have a structure on how you're going to solve the problem. Okay. Then we went about data understanding. Now we said in data understanding, you need to collect the initial data. Now, collect data is a loose sense. It doesn't mean that for every project you have to go to the field write a questionnaire, or develop a tool for collecting data, you may need to go to public repositories to download the data. It is still part of collecting the data. You may need to, you know, have data science companies that deal with data collection hand you over the data. You may follow different approaches to get your data. But one thing I said here yesterday is that you must, as a data scientist, ensure that you're following the um, data protection laws. We did say here yesterday that there are several data protection laws depending on the jurisdiction you're working in. If you're working in the United States of America, there are laws that are you know governing how you operate with people's data there. If you're working in Europe, they have their law. They even having now, they're coming up with the AI Act. So you need to understand the GDPR requirements, like if you're working in Europe, for using a specific data. So you need to ensure that whatever data you're using, you're following the due process. Now, I gave an example yesterday that some companies have been sued by individuals and by organizations for using data without having the right to do so, and they've paid a huge sum in fines. You can find those stories online. So just in case you're working for a startup and you then use the data you're not supposed to use, and you build a wonderful solution that you think is solving a problem, but then your company is now sued to court to pay X million pounds or X million euros or X million dollars. You see, that can drastically reduce the viability of that business. So you need to be careful in that sense. So when collecting your data, you need to ensure that you have the right to use that data. You also need to ensure that the data that you're collecting meets the specification of the project, the objective of the project. You need to also verify the data quality. Okay, so in data understanding, you also need to describe the data, and you describe the data using tables, using visualizations. You use that to describe the data, okay, to get an insight about the data. What is the data saying? Okay. Exploring the data too is the same sense. You're trying to get an insight about what that data is, and then you need to verify the data quality. You need to ensure that the data you're going to use to solve that problem will help you solve the problem. And I did mention here yesterday that if you have a data set and you use the data set in solving a problem, the solution is as good as the quality of the data. If the data itself has poor quality, it therefore means that the solution you're going to be getting is going to be a poor quality solution. So we did set all this yesterday. I'm not going to go so much in detail again. I'm going through this again because yesterday we lost the recording, and several people were asking for the recording and we couldn't produce it because we lost the recording. So that is why I'm going through this again, okay? Another thing you need to understand is the data preparation. Austin, I just need to confirm with you. Are you also recording on your system?
No, I think you are recording already.
I'm recording, but you can also record too. So just in case I have issues. You can also record. I think two people can record at the same time, so you can also record. Okay. All right. Thank you.
Yeah.
All right.
So,
So data.
so you can record locally. So yeah, so that we can have.
I'm recording locally. So you guys can one other person can also record. So just in case, so that we don't have the same issue we had yesterday.
Yeah. Thanks.
All right. All right. So data preparation. Now this is where you prepare your data, and you prepare it in a form that you can use for modeling, right? You prepare it in a form that the computer can understand it in terms of processing it. You prepare it in a form that you get to understand, you take away all the irregularities about your data. So for example, you need to select the data, you need to clean the data. For example, if you have outliers, if you have missing values, if you have null values, you need to know what to do to those values. You need to correct that, right? You need to construct your data. You need to say, do you need to scale your data if you're doing a modeling? You need to integrate this data. You need to format the data, to put the data in a shape that you can use for modeling. Next week, we'll be looking at modeling, and then you'll see the importance of doing this. And you have a very good anchor there next week, which is Dr. Austin Okoli. which will be taking you through that. So you're going to have a good ride then. All right. So for modeling, we are looking at to select the modeling technique that we need to use, the right technique. So you don't need to use a technique that is not supposed to be used. So you need to know for this specific data, considering this specific problem, what modeling technique do I need to use? So for example, if you're doing a prediction model, or if you're doing a classification problem, and then you're using a regression model for a classification problem, you're already using a wrong technique for the problem. And you probably, for example, what you want to do is clustering. You want to cluster your data, for example. And then you're then using classification for clustering. You're already on a wrong boat. So you need to know the specific technique you need to use for a specific problem, right? In terms of modeling. You also need to generate a test design. How are you going to test that this model that you've developed is effective? How are you going to test it? Okay, so you know how to design your test, your test set. And then after designing that, you build your model. And then you need to assess the model. Is the model overfitting? Is the model underfitting? You need to assess the model, right? If the model is doing exactly what you want it to do. Because sometimes we build a model, you have high accuracy, but you don't go to check, okay, sanity check on the model. Is this model doing what exactly it needs to do? Let me give you an example for that. When you build a model, you test the model on the test set, and then you get a specific value. For you to know if there is overfitting, you need to do some different techniques. There's several ways to find out for overfitting. If the model is performing very well on the training data, you're going to know about training. What is training data? Training data is the data you use to develop the model. Test data is the data you use to evaluate the model. So if the data is performing very well on the training data, but very poorly, significantly poorly on the test data, it tells you that there is overfitting, because the model is able to understand, to cram the data, but it's not able to generalize properly, right? So you need to know how all this, works. And then if it is poor on the training and it's poor on the test, that is underfitting. So the model did not understand the data properly. So you need to know how to do a sanity check on your model. And then you do need to evaluate the model to see what result is it producing, review the process, and determine what you're going to do next. Okay, so what you're going to do next now may be that you want to deploy it as a software for a service, or you want to deploy it using an API calls. You want to produce a report, probably is a proof of concept, probably is a patent, probably is for a paper for publication. Probably you just need to write a report about it. Probably you want to write a blog post about it. Probably on so you need to know how you're going to, get this model or get this solution that you've built out there. All right, so that's the data science methodology we covered. And we did also cover last week, yesterday, that what is exploratory data analysis. So we said exploratory data analysis is using variety of techniques. Emphasis on the word variety, okay? In exploratory data analysis, you're using variety of techniques to gain insight about the data. And the reason why you need to gain insight about your data is so that you understand the specific techniques that you need to apply to that data, so that you understand what will be the correct methods to apply to that data. All right. So you also need to understand how to clean the data, how to pre-process the data, what statistical analysis to do, what kind of visualizations do you need to do in order to come up with a very good result. Okay. So one of the importance of exploratory data analysis is that it improves your understanding of the variables in the data, because for example, when you get the mean, the minimum, the average, it helps you understand how the data is. It also helps you discover the errors, the errors in the data. If there are outliers, if there are missing values, it helps you understand that. Now, why we need to understand this is because there are some models that are sensitive to missing values. So if you're using them and you have missing values in your data, you more or less would have a wrong answer or a wrong solution. So you need to know how to remove those missing values. All right. Now, most of these things we're telling you, you need to jot them down. So as I'm taking this class, you need to jot them down because we may not cover every single detail of some of the things I'm saying. But when you know that these things exist, and even if we do not cover them, it is your duty, because you are in charge of your own learning. It is your duty to go and seek the knowledge on what those things are and how to perform those things. Because if you're expecting that you will gain every knowledge you need to gain in any single class, even if you're studying MIT, it's not possible. Even if you're studying Harvard, you can't gain every single knowledge from a class. You have to do your own work outside of the class. So some of the things we are mentioning, we may not cover it, we may cover it, but you need to jot them down so that you know that these things exist. And if we don't cover it, we will cover as much as possible. We'll do our best to cover as much as possible. But if we don't cover it, then you go home and you do your work. That is how you build your skill, okay? So another reason for doing another importance of exploratory data analysis is that it helps us identify the patterns, by visualizing the data in graphs, such as bar graphs, scatter plot, heat maps, and histogram. Last week we did see some of these heat maps and all that. All right, thank you. I will just stop sharing my screen now. And then I'll stop sharing my screen now, and then I'll go to the Jupyter notebook, where we would then talk about other things, the practical aspect. Okay, so if you don't mind, I would take 5 minutes to catch my breath. As you will observe, I talk so fast, so I need to catch my breath, take some breaks. So I'll take 5 minutes to catch my breath, get some water, drink. So you can also do that, and then we'll continue, okay? Catch you in the next 5 minutes. All right, guys. Welcome back again to the practical section. I believe you're all ready and fired up for it. And at least you've taken your stretch. It's always good to stretch when you're studying. Don't sit for long hours without taking stretches, you know. It helps. All right, so let's continue with our class. Okay, so I will continue with the practical aspects, okay? I have gone over so many of these things yesterday, so it therefore means that I'm not going to be spending too much time on them. I'm just going to be going over the key points up onto where I stopped yesterday, and then I will then continue from there in detail. So you would bear with me because we've done this already yesterday, and we are just doing this because of the recording. All right, so yesterday we made use of the Californian housing data set, and we use this to perform different analytics, right? To different data exploratory techniques. And our goal yesterday, before I continue, Austin, is there any question that we need to cover?
Yeah, no, for now.
Okay, none for now. Okay, I guess most of these we already done detailed yesterday, so I guess those questions we already asked. All right, good. So yesterday we used the California housing data set, and we said you fetch it this way, and then we have the data set, and the data set we said it was made up of mostly, let me do display, let's see, good. All right, so we said it is made up of we did the shape of the data. Yes, so it's made up of 9 different columns and to 20,640 different rows. And we show that this is it here. It's 0 indexing. So it starts from 0. So you can see that it's 20,640 rows and it is 9 columns. So this is a data frame. Now a data frame is made up of rows and columns. And we wanted to explore this data to understand this data. And remember, we said that it is all made up of numerics. So first, one of the things you can do to explore the data is to understand the type of the different features. All right, what is the type of that feature? Is it a string? Is it a float? Is it just numerics? Is it an integer? What is that feature? How is that feature? What is it? So one of the ways of doing this is to do this variable here, housing underscore df. We said it is the variable that holds the data set or the data frame, right? And you do housing underscore df dot d types to understand the data types of the different features. All right, so you have the different features here and you have their data types. And another way of doing this again is to use housing.info. Now, housing.info, the good thing that it does for you is that it not only tells you the data types of the different features, it also tells you if there is a null value or there is a non-null value. Okay, so you can see that for each of these features, there is no null value, so it's a good thing. Now, we also talked about shape, and we said shape is used to understand how many number of rows do I have in the data set and how many number of columns do I have in the data set. We said the first value that you get is the number of rows, and the second value you get is the number of columns, okay? There may be a need for you, Dr. Austin. If you don't mind, you can give them this updated notebook. You can share this updated notebook to them because I've done some additions towards the ending.
Okay.
So you can share it with them.
Yeah.
All right. So we also said another thing you need to explore on your data is to understand if there are null values, right? If there are null values, you need to know those values. And the way to do that is to say the data set itself dot is null. So you're saying that for each cell in the data, is there a null value or not? So if you do this, normally you're going to have the data frame, the same data frame that you had before. And then you're going to be having false, 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 or true and false. So wherever there's a missing value or wherever there's a null value, you will have true. Wherever there is no null value, you have false. Now, we did say that it is difficult for you to understand how many number of null values there. So the way to do that is to use the same thing again. Housing dot is null dot sum. Now, what that does is that it sums the total number of true values for each column, and it gives you the result. So we can see here from the result that none of our future has null values, which is what you normally wouldn't have in a real world data set. We said this is a data set that is very clean. In the real world, you would have several null values and you will need to know what to do about them. All right. Now, another function we talked about yesterday is the describe function. We said the describe function is mostly used when you have numerical futures and you're trying to understand the count of the future, the mean, the standard deviation, the minimum value, the maximum value, the median, and the likes. So that helps us do that. And we did show the result here. Another function we did talk about is correlation. And we said correlation has to do with the relationship between two variables, okay? So, or two futures. So you want to find the relationship between futures. How do they relate together? And we said correlation, there are two things you need to understand about correlation. We said you need to, excuse me, you need to understand the strength of the correlation and the magnitude of the correlation, okay? You need to understand the strength of the relationship. It means that values that are close to 1 are stronger. Values that are close to 0 are weaker, right? So if two futures have a correlation, whether it's negative or it's positive, it doesn't matter. In as much as that value is close to 1 or is close to -1, it tells you that the correlation is strong. If the value is close to 0, the correlation is weak. Okay, we said that. And then we said the direction of the correlation tells you if it is positive or negative. That's the direction. Now, a positive correlation, it means that when the first variable is increasing, the other variable is also increasing. When it is negative, it is inverse. It means that when one variable is increasing, the other variable is decreasing. And we showed it here. So the function to do that is call. So you do the future, the variable name dot call. Now what that does is that it tells you the correlation. And we did say that every future is perfectly positively correlated with itself. It means that the correlation between a future and that same future is 1. So you see that the diagonal here would just be 1, 1, 1, 1, 1, 1, 1, okay? Because every future is perfectly correlated with itself. And then we then showed that some of the features are negatively correlated, some are positively correlated. Now, the difference between this and having the heat map is that the heat map would help you visually see what correlations are there. It will visually help you see that easily. So that is why we said the heat map is very good. It's very effective. And we did say that how you understand the heat map is by understanding this legend here. So it means that if the correlation is 0, it will have this color here, right? I think I can get something. Oh yeah, I should get this. Okay, so this is it here. So we did say that if, for example, you're having a correlation of 0 between two futures, the color will be this color here. And the more red the color is, the more perfectly positively correlated they are. So that's why you could see here that the diagonal is just red, meaning that every future is perfectly correlated with itself, okay? And we did say that the more blue here you see here, the more blue it is, the more perfectly negatively correlated those features are. So for example, this feature here, latitude and longitude, they are negatively correlated and they are strongly negatively correlated. That's why you're seeing that it is 0.92. 0.92 is close to 1. So they are strongly negatively correlated. And we also showed that when you do the peer plot, right, you could see this observed in the peer plot. So you could see this here. You could see this observed because this shows an inverse relationship, while this here shows a linear relationship, right? So you could see this different behavior. You could see that this distribution here is somewhat skewed to the left. So we said that the good thing about the peer plot is that it gives us a visual representation of the distribution of the futures with themselves and with the respective peers, right? We did discuss all that yesterday. And then the color that we have here must not be the same. Sometimes you may have green and another color and purple. It must not always be red and blue. So you need to put an eye on that when you're doing your heat map. Okay. Then yesterday we went to another data set, which is the iris data set, and that data set has to do with the different categories of, or the different iris flower species. So we said there are 3 different species. We have the setosa, the vesicula, and the virginica. So these are the 3 different species. And we said this data has, if you look at the shape of the data, I think we looked at the shape of the data somewhere. Okay, let's do that here. Let's do this. Let's say iris dot shape. Sorry, dot shape. So we see the shape of the data. So it means that the data has 150 rows and it has 5 columns. And the first column is the sepal length, is a numeric feature. We can see this by doing our D types. So we can call this the data dot D types. We can see this. Good. Another thing you can do is to say iris dot info. That's another thing you can do. Good. So it shows you here. Okay, the data has already been formatted. That is why you're having int here. Because let me run the data from the beginning. You wouldn't see that int. Shape is still the same. This is still this. No, it's not object. Yes, good. And then this will not be object because this we have not transformed it yet. Good. So all right, good. All right. So we said that we are concentrating on this species. So you have the sepal width, the petal length, and the petal width. And then you have the species, and the species are 3 different species. Now the species is the target, meaning that the species is the variable of interest. You want to know the species of a flower given the sepal length, the sepal width, the petal length, and the petal width. Now that's what you're trying to do. You're trying to know the species given the lengths and widths of the sepal and the petal, okay, of that flower. So it's a very popular data set that we use for data science teaching. Okay. So we said if you want to use this data, you need to first of all convert this species column to what the computer can understand, because you can give setosa, for example, which is like setosa is like a text. You can give it to the machine learning model and expect that the machine learning model will understand what you're talking about. For most of those models, you need to convert it to numeric, for example, but the numeric you're converting it to does not have any inherent meaning to it. So if you say, let's setosa be 1, and where do we have that here? If you say let's 0 correspond to setosa and 1 correspond to vesicular, it doesn't mean that vesicular is 1 greater than setosa. No, it doesn't mean that. It's just a label, right? So that's what we needed to say. So first of all, you can use the function iris.specie. Is you're telling the data set that you want the column specie, and for that column specie, you want to find the unique values that it has. You want to see how many unique values that it has. And it tells you what are the different unique values that it has. Another thing you can do is this. I think you can, let me try this and see if it works. So you can do value underscore count. The same thing, iris.species is that you're specifying that this is the variable, this is the data set itself. Dot species that you're specifying here the column, right? You're specifying that column, that specific column, because you have the column specie. You're specifying that column specie. And from that column specie, you want to find out the value count. The value count in the sense that you now know that there are unique values here. The unique values are setosa, vesicola, virginica, right? But you want to know how many values or how many rows belong to this, belong to this, belong to this. How many rows belong to that? Now, the way of doing that is to use what I call, you can use the value underscore counts function, value underscore count function. So this shows you that each of them have 50 rows, and in total you have 150 rows. So they are evenly distributed. Sometimes when you're working, I'm going to say this now, this is for your learning, this is for your knowledge. When you're working on data science project, it is not always true that the target variables or the target, if you're working, for example, on a classification problem, it's not always true that the categories will be even. You may have a situation whereby you're having more rows for a specific category and less rows, significantly less rows for another category. Now that now leads you to imbalanced data sets. And the way you deal with imbalanced data set is different from the way you deal with balanced data set in terms of modeling. The way you evaluate the result of an imbalanced data is also different from the way you evaluate the result of an evenly distributed data in terms of modeling. So you need to have this in the back of your mind. If you're running a classification model and you hit an imbalanced data set, the way you're going to treat it and the way you're going to evaluate it would be somewhat different from the way you're going to evaluate it when it is evenly distributed. Now, this is not related to what I'm teaching here. I'm just putting it out there so you just have it at the back of your mind, okay? So we move on. So the next thing we wanted to do is to find out if there are null values in each of these columns. So we do it, you've already seen this function before, iris.isNull.sum, and that shows us that we don't have any null values, which is very good. We're also trying to now pre-process the data, right? And one of the ways of encoding that column, which is, remember we had a column that is, what's it called? That was the species column, and the species column was in text. Now you want to change it in such a way that 0 will represent setosa, 1 will represent vesicular, 2 will represent virginica. Now the way to do that is to use label encoding. And we did say yesterday that there are different types of encoding. You can read that up yourself. You can also manually specify it here. You can manually specify it here. You don't need to use label encoding. You can manually specify that iris, the data set, dot replace. So wherever it sees setosa, it should replace it with 0. Wherever it sees vesicular, it should replace it with 1. Wherever it sees virginica, it should replace it with 2. You can manually do this. But instead of manually doing this, you can just use from the pre-processing function in scikit-learn, you can use the label encoder. And using the label encoder, you can then see that this is now labeled 0, 1, 2. And if we find the unique, It is now 0, 1, 2. Whereas before, when we found unique values, it was this. Okay. I'm going to pause here and then see if there's any question before I continue. Any question?
No.
Great. So we've covered most of these things yesterday. So I think there should be no question. Right. So you also know now the describe function and you know the call function. So we use the same thing on our data set here. And we have those results and we want to see the species count, right? Yeah, we're using the Seaborn package to make a plot, a visualization of the target of the species, right? So we are using that here to do like a visualization, a bar chart, you know, that tells us how the different species are distributed, and you can see that they are evenly distributed. Now this confirms why we saw here that you have 50 50 50. So you could also see it here that it is 50. It is 50 here. So they are evenly distributed. Okay, so this is how you do it. You do SNS. SNS is coming from the Seaborn package. Remember when we imported, we said import Seaborn as SNS. Do we have that here? Look at it here. Import Seaborn as SNS. So this is what you're calling first. Import Seaborn as SNS. So this is the SNS that you're calling, right? So in case you're asking where is the SNS coming from, that is where it is coming from because you're importing Seaborn as SNS. So we call that package because we need to use that package to create this visualization. So we call that package, then we say dot count plot. So this is a count plot. What it does is that it counts the number of the different categories and makes a plot of it in a bar chart. Okay. And that is it. So data equal to iris is that you need to specify the data that you're working with. And the data we are working with in this case is iris. If your data is named something different, if your data is named data, you need to put data is equals to data here. If your data is named DF, you need to put data is equals to DF here. So depending on what your data is named, that is what you're going to put here. Now, what you put X here is that this is the X axis here. The X axis. What you're specifying here is the specific variable that you're trying to find, the count plot. That specific variable is what you're going to specify as X here. So I've said this here. How do you make the count plot? Is that you call S and S, which is the Seaborn package, dot count plot. You specify the data set, data is equal to iris data, and you specify what the x-axis is. So you put that x-axis is species, and species is that you're dealing with this column here, right? And then you would have your beautiful plot here. Now, there is a way you can improve on this plot. You can add the plot title. You can add the plot, what you want the y-axis to be called, the x-axis to be called. You can always edit this plot to look the way you want it. If you want to probably change the colors, you can change the colors. You know, there are different ways on doing this. I believe I will leave that for you to explore, right? I will leave that for you to explore on your own time. Explore how you change the colors. Explore how you change the colors, how you write the name for your x-axis and your y-axis. There's a plot down that will show you how to do that. But I will leave it till I get to that point. Okay, look at it here. It's already here. So good for you. So now in this plot here, we are trying to make a plot here. So what plot are we trying to do here? This is a scatter plot. It's a scatter plot of two variables. Now, the variables here is the sepal length and the sepal width. We want to find the distribution of the sepal length and the sepal width. Is there any relationship between the sepal length and sepal width? We would like to find that here. Okay, so the way to do this, you're using the matplotlib package now. This is not the Seaborn package you're using now. You're using the matplotlib package. So this is where you are specifying the size of the plot. That's what you're doing here. Excuse me. Now, PLT is what we use to call the matplotlib, because we said let's matplotlib, import matplotlib as PLT. So when we say PLT, this is the PLT we are meaning here, right? So you need to know that, okay? I'm saying all these things because this is an introductory class. Mostly when we are teaching advanced classes or intermediate classes, we don't go into this kind of noise detail because we assume you already know it. But because we are dealing with people from different background here that are just coming into the field, and some of them are seeing Python for the first time, that is why we are taking our time to explain all this. So that's one thing you should know. So we go there. So we have the plot here. So plt.figure. So we specify the figure size. Then plt.scatter. Now this is the function that does the plot itself, right? You could see here that the function takes in parameters, different parameters. You can see the parameters it takes in, right? It takes in X and Y. So which are the float or array-like shape, and the shape has to be N. So it takes in that parameter. So our X here is the iris sepal length, and our Y here is the iris sepal width. So Y is iris sepal width, and this is X sepal length. So if you double click on this, it will kind of show you. Yeah. Okay. So then what we did here is the title. So plt.title is trying to specify what we want to call the title of this plot, right? Plt.title. So see if you're going to use some of these things here to explore this here. Let's see. Let's try something. It may not work. It may work. Let's see. So remember what I told you? I told you that you can edit this plot. You can specify the title of this plot. So this is how you do it. I'm giving you an idea. So the plt.title. So now what is this? This is a count plot. So you can change it here now to say count plots. Count plots, sorry, count plots of species. So you can just do that. So count plot of species. So now it specifies a title for you, right? So you do that using plt.title. You can always change this, remember. So that's the same thing you have here. So this is here. This is to specify the title. This is to specify the name of the x-axis and the y-axis. So these two here. So plot plt.show is just to display the plot, okay? So that's the plot we are having here. So you can investigate it to see if there's any pattern that this is showing. So I am not seeing any nice pattern here, any well-behaved pattern. Maybe some other persons have better eyes and they can spot this out. So if you can spot out any pattern here, you just put it on the chat box. And then Dr. Austin will look at it and tell us. So put it on the chat box, okay? Let's do this. Let's do this. Guys, no sleeping. I hope no one is sleeping. Put it on the chat box. Do you observe any pattern here? Type if you observe any pattern. If you can't observe any pattern, type also on the chat box and say, no, I cannot observe any pattern. I'll give you a minute to do that. Let me see what the chat's it's saying. Dr. Austin, is anybody telling you about any pattern that they're observing?
Yeah, I don't know, but someone said I did not understand the last part of coding categorical variable to numerical.
The last part of categorical numerical, what exactly don't you understand? Can you be more explicit about what you don't understand? Is it the explanation? Is it the coding? What don't you understand?
Yeah.
Is it the explanation?
I
Is it the
think
concept? Or
I think it's the coding. I think it's the coding of how you coded the categorical variable to numerical. You know, like the category of the yes, this Setosa.
Okay.
Yeah.
Okay, that's fine then. All right.
Yeah.
All right. So this is the part you're talking about then. So this is the lines that you don't understand. So these three line, sorry, these two line is the line you don't understand. So it is
Yeah.
this two line that does the encoding for us. These two line that I'm showing you here that does the encoding. So the first, this is what we are doing here is that we are specifying the function that we are going to use to do the encoding. We are saying let that function be called LE, L-E. You can call it anything. You can call it encoder. You can call it, but in as much as that, whatever you're calling it is not a function, a default function in Python. It's always good not to use default function names in Python to call variables. It's very important. You don't do that. But you can call it anything. So this is equal to preprocessing. This preprocessing is coming from the sklearn package. Let's see. So you could see it here. We said from scikit-learn import preprocessing. So you need to understand what this package is. This package, okay, let's just do something. One of the ways of understanding is you just go, okay, you go to your Google, you said preprocessing package, scikit-learn, Python. So it will tell you what it does. So you could see it here. A scikit-learn preprocessing package provides several common utility functions and transformer classes to change raw future vectors into a representation that is more suitable for the downstream estimators. Okay, so you're basically, there are jargons there. Let me help you understand it. It's simply telling you that when you have a raw future is the kind of feature where you have Satosa, you have it spelled Satosa, you have it spelled vesicula. That is a text, right? So that's the raw feature. It is a text. But you want to change this text to a representation, to a value that will be understood by the machine learning models, or that will be understood by the algorithms. So you want to change it to 0, 1, 2, right? If you're using the label encoder, right? So that is what you use that, okay, that for, right? So you can read more about this here. So this is a good website to know. So you can go here and read more about what is this preprocessing, is this package, scikit-learn.preprocessing. You can read more about it here. So there's what we call the standard the standard scaler. We'll talk about this next week, I believe, in the scaling. So now, if you also want to get more understanding about what a label encoder is, so remember, from scikit-learn we imported preprocessing. So when I want to preprocess this, what I did here, okay, let me go here, is to say preprocessing dot label encoder. It means that I want from preprocessing, from that package, I want to import label encoder function. Now let us do the same thing here. Look at it. The label encoder function, I'm trying to tell you what it shows here. The encode target labels with value with value between 0 and number of classes minus 1. So the number of classes here is what? 3. 3 minus 1 is 2. Therefore, you're going to be having a target label of 0, 1, and 2. So this function helps you do that. So this transformer should be used to encode target values, that is the Y value, and not the input X. So what if you want to find out what does this thing, it also gives you an example of how to use it here. You can see how we are using it. Examples. Label encoder can be used to normalize labels. From scikit-learn, import preprocessor. So LE is equal to preprocessing.label encoder. You're specifying the function. lead.fit, you're trying to fit that, right? And then, okay. So if you want to now understand, this is how it works. So if you want to understand some of these things, you can just do this. You copy this, you go to Google, you say this, preprocessing.label encoder circuit length. So you come here, and this will tell you everything you need to know. You know, it said it encodes target values between 0 and n-1. These are that thing I was reading. Those things I was reading on the Google Colab here, they are the same thing that is here also. And then it shows you an example of how it is done. Okay, so I will take it again. Preprocessing is the function where is from where we got the label encoder function. Here we feed transform it to the species. So what we are trying to say here is that go to the species column. Wherever you see setosa, convert it to 0, right? Wherever you see vesicular, convert it to 1. Wherever you see virginica, convert it to 2. That's what we are doing, right? And that's all the function does. That's what the function does, right? If you don't want to do that and you want to do it manually, you can do it manually by saying replace. So you can replace wherever you see setosa, replace it with 0. Wherever you see vesicular, replace it with 1. Wherever you see virginica, replace it with 2. And use only this function and to do the same thing. Okay, so I believe that that is understood. Is it understood? I need to run because there are several things I want to cover up before today's class ends. And there's a nice treat at the end of the class, so I need to run. If you have any question, just put it on the chat box or you put it on the WhatsApp group on that, and we can always go over it again for you. So now we are having the pair plot, right? But we are using the Seaborn package this time around, and it gives us a better view than when we are not using the Seaborn. But we are specifying it to the species. So we could see a very nice distribution here. So this, you need to understand this plot. So this plot, so this is the legend of this plot. So 2 has this dark color, 1 has this color, and 0 has this color. So if you look at each plot, the distribution of this shows you the distribution of this species and this species and this species. So you could see that this is the pair plot, but this is not the kind of pair plot that we saw previously. This pair plot is also with respect to categories. It is with respect to categories. That's the difference between these pair plots and this pair plot. In this pair plot here, we did not specify any category. We did not specify any category in this pair plot. In this one, we did not specify any category. However, in this pair plot that you're seeing here for the iris data, we have specified a categories. So it's giving us the result with respect to categories. And you could see very well behaved patterns here, right? You could see well-behaved patterns here. You could see that this is almost like a normal distribution. This is a distribution that is somewhat scaled. It's somewhat left skewed. This is somewhat like a normal distribution. We're still having almost like a normal distribution here. Same thing here. This is more or less like a normal distribution. This distribution here is somewhat. So you can see some very nice patterns here. I don't want to spend so much time here. You can spend so much time here to understand what these distributions are on your own. So similarly, we have the heat plot, and I've explained what this is to you, so I don't need to go over this again. One thing I just need to bring to your attention is that I told you previously that it's not always that for every heat plot you have the same color, right? You can see that there's a difference in color here. So you need to interpret this with respect to the color, right? So you can see, so the darker color shows that it is negatively correlated. It is more negatively correlated. The lighter color shows that it is more positively correlated. So we have an exercise here. And in this exercise, we are making use of the of the cancer data. So I'll give a little break here because it's more than 30 minutes again. I'll give now, this time will be a 2 minutes break. So you can drop your questions, you can drink your water, and then we'll continue in the next 2 minutes. All right, so welcome back after the short break we had. So this is, you guys will be doing more of this, although we have much of the codes already done for you. But more or less is the same thing that we've been doing, but we're trying to use another data set here. And the data set is a standard data set that we use, and it's called the breast cancer data set. And if you want to find out more about this data set, you can go here, scikit-learn. So you go on your Google, just say load breast cancer. And then you click on this, on the scikit-learn link. It will take you to this page. And in this page, another thing that you need to do, good, okay. So in this page, you get to find out about what the breast cancer data is. This is a data set, I believe, that was developed by Wisconsin University, I believe. So you can read more about the data set. The copy of the UCL ML breast cancer Wisconsin diagnostic data set is downloaded from here. You can also download the data here. But instead of you going here to download the data, this is the breast cancer data. You can download it here, right? It tells you the features here and all that. So instead of you to go through the stress of downloading it here, scikit-learn dataset has some of this data set there. So it has the data there. So you can just load this data directly from a scikit-learn and use it, you know. And there are more data sets. You can find that here in scikit-learn.datasets. There are more data sets here. You can use several other data sets here. So you can see the different types of data sets that are here. We've used the California housing data. You can see that where we use that. California housing data. There's KDD COP data. There are several types of, there's diabetes data set. So just in case you're interested in diabetes, working on diabetes problem, you can just use the diabetes data set here. The Irish data is the one we've also used. We've also used this one. So there are more data sets you can find here. You know, data sets that you can find here, you know. So I will leave that for you to explore. Okay, I will leave that for you to explore. And I will leave this also for you to read more about what the data set is and what the meaning of the data set, the features and all that. I'll leave that for you to explore. I'll leave that for you to explore. So we go back to our work. Good. So we've tried to load this data set, and we called the name, the variable name which we load this data set as cancer. And you can say cancer underscore DF. Anyone you want to say, it's fine. So we call it cancer. Okay, let me just see. So now we're trying to, use that, that dictionary that we've collected, the directory. We're trying to now from there specify the data frame. Okay, we're trying to build the data frame from this. Okay, so if you try to run this, you see what you would get. Let's see. You can see that it is not in a way that you can understand, right? It's not in a way that you can easily use it. When you just say the cancer here, it's not in a way that you can easily use it, right? It's like in a, let's see, type of that so that we can understand what the type of that is. Let's see. What is it? Okay, so it is a dot bunch. Okay, so it's not in a format that you can use. So we then have to now convert it to a data frame that we can easily use, and that is what we're using this function to do. We're using in this line of code, we are trying to convert it to a data frame that we can easily use, and we are specifying the different names, and that we're also specifying what the target would be. So we have this here now loaded as the data set that we need, df_cancer. So you can see, you can find the shape of this data to know how many columns you have and how many rows you have. So the shape, so you have 569 rows and you have 31 different columns. So this is a massive data set, a somewhat massive data set compared to the data sets that we've been using, right? Not massive in terms of the grand scale of data sets, because sometimes you can work with data sets that has 1 billion. There's a project I'm working on now where I'm using 2 million rows, and it's a standard, it's a tabular data set, but there are 2 million rows. So those are the kind of data sets you find, right? But this you can see is 31. So you have 31 columns, all right? So you can find the tail is like you're finding the end part of the data. How does the end part of the data looks like? And I told you that you can specify the number of rows you want to see. So the last rows you want to see, you can, if you don't specify anything, it prints the last 5 rows by default. But if you specify, say, for example, 10, it will print the last 10 rows. That is using tail. If you want to specify the first rows to see how it looks, you use head, the head function. So this just shows you how the data looks like, right? So there's a lot of things here. There's the mean radius, the mean texture, mean parameter, the mean compactness, radius error, and several other feature here. And then you have your target feature here. Target feature, good, all right. So the same thing we did, we will do here again to find out if we have any null values. We do that is null dot sum, and then we could see that we do not have any missing value here. This is not always the case, but for this data set, we do not have any missing value here. The same thing we did again, we do it again, dot describe. We're trying to describe to see. We're trying to describe to see. Let me use display instead of print, because display would display it in a very nice way. Okay, good. So we see. So that is it here for us. We could now see the different, the mean of each of these features, the minimum, the maximum. That is what this does for us. Okay, gives us a lovely data frame with all this, and you already know what that is. Same thing here. We're trying to use a scatter plot to find out, with respect to the target, what is the distribution of the mean smoothness to the mean area. So you could see in this data set that it is somewhat evenly distributed. So it's just like there is a line that separates the data, whereby to the left, you are having the ones with target 1, and to the right, you're having with target 0. Let's find out what is the meaning of target 1 and target 0. We can easily do this by saying, Let's find out the meaning of 0 and 1. I can't remember what it is. Let's find that out. So we copy this, we just go online, then we find out what that is. Good. So we go to this data. So it has 2 classes. What is the meaning of those classes? Let's see. I believe it's one 0 will be for no cancer, and 1 will be for cancer if it is cancerous, and 1 is not cancerous. I believe that is what it will be, but I want to be sure. Okay, let me see. Does this tell me? Should tell me. Yeah. Okay, good. Okay, good. So the diagnosis, is that the target? I don't think so. So I think for now, I'm still trying to find out where we specify the meanings. Yeah. But you have in your target variable, you have two categories, and 0 would be for, I believe, would be if it is not cancerous, and 1 would be if it is cancerous. I believe so. But you can confirm that by just understanding the data itself. That's that. Now this comes to data understanding. I don't really understand the data set properly in terms of what the target variable mean. So you need to, go and check that out, and then properly understand what that is. I believe here should be, so the information should be somewhere here, but I don't have the time to explore that. Okay. So the same thing here, we also want to do a bar plot, and still it's almost the same way you saw previously. So you're specifying that we want to do the target. We want to see how the target variables are distributed. So you see what I told you before, that some target variables, they are not always evenly distributed. Sometimes 1 is more distributed, 1 is more than the other. So you could see here for the 0 target, it is less than the target of 1. All right. So probably 1 may mean that not cancerous, and 0 may mean cancerous, because you have less people with cancer compared to people without cancer. Right. So I believe 0 would mean cancerous, and 1 would mean not cancerous, right? So that is it. Okay. So we have a little challenge here. I will not go into this challenge. I will leave this challenge for you to walk through yourself, and then I'm going to go to the last part of this notebook. So this mini challenge is for you. We are not to go through this for you. You should go through this, try to understand what's being done here, and try to replicate the same for different variables. That is the challenge we have for you. So you go through this, understand what is being done from this part of the notebook, from this mini challenge part, and try to do same, like something like this here, where we are doing a distribution plot. We are doing it, for example, for mean radius. There are other features. Do the same plot for other features, right? For this too, right? We are doing the target. We're doing this plot, the scatter plot with respect to the target for these 2 variables. Do it for other variables. That is the challenge we have for you. That's what we have for you. So we have the solution here already. And I believe you also have the solution already. But we want you to explore more, right? We want you to explore more, right? So it means that we've given you solution for some of them. We are not going to go over it. We want you to go over it yourself, understand what is being done, and replicate that for other futures, okay? That is the target we have for you. Do the same thing for the Titanic dataset. Go through that Titanic dataset. Try to understand all the different things we did all the different preprocessing we did, all the data checks we did, all the other data sets, do the same thing for the Titanic data set. Okay? So you know your assignments now, or the things you're going to work on. For the breast cancer data set, try to understand the data. I did not explain what the data is, and I did that on purpose. The reason is because we want you to go and gain the data understanding of the cancer data. So that's your assignment. Try to gain data understanding on the cancer data. What does that target variable, what do they mean? Then for each of these plots we are doing here, replicate that for different features. So we want you to submit to have that ready. And we're going to look at that next week before we continue to the next class. Another thing you need to do is also look at the Titanic dataset. We already show you how to load the dataset here. Then perform all the sanity exploratory data analysis. Perform different exploratory data analysis on this Titanic data, right? So that is what we have for you there. Good. I'm going to give you another 2 minutes break. And when I come, I'm going to tell you the part where I know most of you will be interested in. The part where most of you will be enjoying. This part, you don't need to do much. The computer does the much for you for this part. So I'll give you 2 minutes again for break, and then I come back. All right, guys, you're welcome back to the last part of today's class. I hope you've been enjoying the class so far. And we've been dealing with exploratory data analysis. We started off talking about the different data science methodologies. We then talk about specifically the Cripps DM methodology. We looked at that, and then we then started with exploratory data analysis. We've looked at several data sets here today. We've looked at the iris data. We've looked at the cancer data. We've also showed you the Titanic data, some of all those things. And we've given you a challenge. So during this week, when you go home, okay, I know you're already in your home, right? So you continue with your learning, and we told you what you need to do. For us, we've told you that. Now, I want to show you all what we've done so far is nice and is good. It's lovely. But what I want to show you right now is something that I didn't learn early when I was learning data science. I learned this on my own quite later. And then I wish that, wait, how I wish someone told me this earlier on. But yeah, this is a good aspect. So the automated exploratory data analysis. Now, researchers have been so good to the point that they've developed techniques or packages that will automatically explore the data for you. So you basically don't need to explore it yourself. It automatically explores it for you, all right? So this is what this automated exploratory data analysis is. So one of the packages that does that for you automatically is what I call the pandas profiling. Pandas profiling. Pandas profiling would help you automatically explore this. Now, if you're running this, make sure to load this. Make sure to load this. If you're running this on Colab, every time you run it, make sure you do this, whereby you install the package. If you're running this on your local machine, you don't need to do this every time. Okay, because on your local machine, it is you install the package once. But if you're working on Colab, every time you need to install this package. I'm saying this carefully because some of you would have issues running this, not because of there are issues with the code, but there are just issues with the way because you've not installed the package. So this is pandas profiling. Now, how do you use this package? This is it here. So here I'm trying to create a data set here. I'm trying to create a data set. I'm trying to create a sample data set that I'm going to use for this pandas profiling. I'm just creating a random data set that would have 30 rows and 4 columns. So it's just a random data set I'm creating. I'm using this to create that. I'm not going to spend much time on that. If you want to know how to create data sets randomly, I've showed you how to do this. Copy this, put it on Google. You will get to read deeper to see how to make data frame. So, or read about this function, make data frame. You will get to read more about that. I don't want to do that. So the emphasis here is that you've created a data frame. I can show you how the data looks like. We can do the head of this data to see how it looks like. So I have 2 data frames here. I can do the head of the first one. Okay, this is the second one rather. Yeah, good. So we see how it looks like. That's how the data looks like. It's the random data that I created. df1 dot head. We want to see how this looks like. This is also another one that I created. So these are 2 different data sets that I created, randomly created data sets. So the df2 contains both this is like a time column, right, where you have specified time. So this will help you. So for example, you're working with the time series data. You have more or less these columns always when you're working with time series data. You have others here. So in this data set, df1, they are just numerics and they are floats, right? So you can see them here, right? So this data set is not the issue. I'm not dealing with data set now. The most important thing is this line of code, this next line of code. I'm here now. How do you use this function, the pandas profiling? So first of all, you need to download it. If you're working on Colab, you install it, you install pandas profiling, then you import it here. So you import pandas profiling here. So when you import pandas profiling, then you say profile equal to pandas underscore profiling dot profile report. Then you specify the data frame. Then here is just like you're just putting back what you have here for you to see the result. Okay. When you run this, it runs and it gives you a report of you exploring the data. It gives you the report, it gives you an overview first, then it gives you detailed about each of the variables. It gives you the interactions between the variables. It gives you the correlations between the variables. It tells you if there is a missing value. It tells you what is the sample size. So it does all this for you automatically. However, if you have a large data set, like 2 million rows, sometimes pandas profiling may not be able to generate it for you, may not be able to generate a report, or it may take a longer time to generate a report. So you may run this code. If you have a large data set, it may take 3 hours before it can generate the report. Sometimes it can take 4 hours and yet it will not generate the report. So it is not so good when you have too large data sets. Okay, but if your data set is reasonable, in a reasonable amount of time, it will be able to generate the report. So now let's go through the report. Now, first, it gives you an overview. Okay, it tells you number of variables, that there are 4 variables, number of observation, there are 30. It checks for missing values, and it tells you that there's 0 missing values. You see, this is done automatically for you. You don't need to do it yourself. How many percentage of missing values you have? 0%. It has already told you. What is the total size of the data set in the memory? It tells you the data set size. Then it now goes to the variables. Okay. Here you can definitely specify the variable you want to talk about. But it does for each of the variable. So for this variable called A, it shows you the distribution, shows you the minimum value. It tells you the maximum value. You can get this using describe. Remember, we did that using describe function. Describe function to get this. But now you don't need to write describe. It has already come out with all this. It's beautiful. Isn't this beautiful? Come on, man. Think about this. This is beautiful, right? So it tells you how many number of negative values do you have? How many zeros do you have? You have 0 zeros. How many negative values you have? You have 17 negative values. How many distinct values do you have? You have 30 distinct values. Okay, so this is kind of, does the same thing for C, D. Then it goes into interactions, okay? The scatter plot that we were doing previously, where we are doing it manually, it has already done it for you now. This is the scatter plot between A and D, variable A and variable D. That's the scatter plot. It has done it for you beautifully. The heat map that we did previously, this is the heat map here. If you want to see the heat map in terms of tables, just click on table here. It shows you the heat map in terms of table. Remember, we did heat map twice. We did heat map showing you the values in tables, and we did heat map when we showed you the values in a visualization. And this does it for you. Oh, come on. If you like this package, just go on the chat box and say, I love this package. I want you to be awake. Okay. Also, in terms of missing values, it does missing values analysis for you, tells you how many missing values are there, and shows you a matrix of them. It does that for you. So that's all about the pandas profiling. It also tells you the samples, right? It gives you some very good stuffs here. So that's for pandas profiling. So that's one package, pandas profiling. Excuse me, let me catch my breath here, please. Now, there's another package that you can also use, all right? That package is called AutoViz. AutoViz, okay? It's another package. This package also, you need to install it. And if you're running on Google Colab, you need to install it every single time that you're going to be using that notebook, right? So install pip install AutoViz. This function here, or this line of code here, it just installs the package AutoViz. Now, when you install that package, now I'm going to be using that package. What I'm doing here is matplotlib inline. This text, this line of code just helps you display the visualization in the same, it outputs the visualization for you, right? Now you could observe that I did something here. This is the housing data set. I'm using the California housing data set, but I specified the path. And you may ask me, how did I get this path? I got this path by clicking here. You see this box here? Click it. click this sample data. You will see all the data sets you've loaded. You see them here. So you can come here, California housing test. You can click it here and you copy the path. If you want to use the California housing train data set, you can click it here and you can copy the path. Okay, anyone you want to use. I was using the test to just show you how this package runs. So you can do it whatever way you want. Okay, good. So this is this line, this here is just specifying the path. So you create the class, the AutoVis class, and you call it AV. And then you say AV.AutoVis, then you specify the path of the data, the CSV data. Good. And then you run that. Once you run it, it brings out this beautiful visualization. Now I'm going to tell you the importance of this. The importance of this is that it tells you for each feature, it tells you if there is a concern with that feature. It gives you an idea if there is an issue with that feature that you need to deal with. Okay. Let me give you an example, right? Good. So sometimes if you don't understand, because remember when I was telling you, when you're doing your exploratory data analysis, you may need to drop some features. You may need to do some particular tests on some certain features, but you may not know the statistics to do because you're not so conversant with different statistical techniques. This package can help you understand the different statistical packages that you may need to treat the data. Now let's go line by line. So it gives you your result here. So you have here, the first column here is telling you the feature names, longitude, latitude, housing median age, total rooms, total bedrooms. You've seen this before, right? It tells you the D types, the data type. It tells you if there's a missing value, the second column, the third column rather. It tells you if there's a unique value, unique values. It tells you the minimum value. It tells you the maximum value. And then it gives you, it raises issues. If you think there's an issue with that variable, it will raise it here. So for the first column, for longitude, it said there's no issue. For latitude, it says has a high correlation with longitude. Consider dropping one of them. So remember, when we did the heat map of longitude and latitude, we saw that longitude and latitude are highly negatively correlated. Now, when you're developing a machine learning model, depending on the type of model that you're using, if you put features that are highly correlated, sometimes you can get erroneous results. So sometimes you need to drop features. If they are highly correlated, you need to drop them. You need to drop some of them. So this is already flagging it to you that, listen, this feature here is highly correlated with this feature. So you may need to drop one when doing your modeling. Now let's go to the next one. It says, has 182 outliers greater than the upper bound or lower than the lower bound. So it's telling you that this feature called total rooms, it has outliers. So you need to, if you think that you need to work on outliers, there's something you need to do that there. The same thing here, there are outliers, and it tells the number of outliers. Outliers are not always a bad thing. They're not always a bad thing, depending on the data. Like for example, total bedrooms. If you have 175 outliers, there are some houses that are mansions. They have like 8 bedrooms. They have 20 bedrooms. Some houses are mansions. They have 20 bedrooms. If Buckingham Palace was part of this data set, Buckingham Palace has several bedrooms. So it may be that this is not a wrong theme, right? So depending on the feature, but what this package does is that it raises flags for you. So you can easily understand now, okay, I may need to do this to this feature. I may need to do this, okay? So that is for the AutoVis package. So I've told you about 2 packages now. I've told you about pandas profiling. I've told you about AutoVis. I'm going to the next one, the third one, right? The third one is SweetVis. SweetVis. I like the name. SweetVis. Now, SweetViz is a nice package. It also, you use this package for automated exploratory data analysis also, the SweetViz package. Now, this is the data set I'm using, the DF data set that I created. So again, you need to install the package. You need to install the package. So this, what I'm doing here is to install the package. And again, you need to import the package. After importing the package, you need to put the report. So my report equal to SweetViz.analyze df. SweetViz.analyze df. df is this data set that you're specifying, the name of the data set. Then you can put a name for the report, and you put a name for it, because now you want to show it as you want to show, because it normally, if you run this on your local machine, what it does is that it generates a HTML file. So you need to show that HTML file on your Pandas notebook. That's what I'm trying to do here now. So from IPython display, import display and HTML. So I'm trying to use this to display the report that it has created. All right. But the main function here is SweetViz.analyze, in brackets, then you put the data frame. Then what I'm doing here is that I'm just trying to display what it has analyzed so that we can all see it, right? So that's what I did there. Now, this is the result it shows you. The SweetViz package shows you. I see. Okay. So for example, it shows you number of missing values, number of distinct values for A. This A here is the first variable. You see, it tells you if there are duplicates. Are there duplicates in your data? No duplicates. How many number of features? How many categorical features do you have? 0 categorical feature. How many numeric feature do you have? 4. How many text do you have? 0. It shows you that. Let's click on association. Okay, click. Good. So now it now goes to each of the features. It tells you the maximum, the average, the median, the first quartile, the third quartile, the mean. We can get this using the describe function, right? Remember, we can get this using the describe function. And then it also does a plot for you for each of them. It gives you a distribution of how that variable looks like. A distribution. It does the same thing for the second variable, does same thing for the third variable, does same thing for the fourth variable. So that is the SweetViz package. Okay. So I've told you 3 now: Pandas profiling, AutoViz, SweetViz. The last one, I will not display it for you. The last one is one of the best of them. And the last one, which is I call detail, is detail, not I call it. I was not the one that developed the package. So detail is very detailed. That's the best thing I can say about the detail. The detail package is very detailed, and it helps you if you have a large data set, because it can display on the browser. It will display on your browser. And mostly I normally use this when I work on my local machine, and I've not used it on Google Colab. You may have issues when you're using it on Google Colab. You may need to see how you can sort out those issues, but I will leave this as an assignment for you. Detail will show you the visualization on the browser, and it's effective when you have a large data set. I told you that I was working with 2 million data sets previously in one project I was working on. The Pandas profiling could not produce a report for me, but Detail was able to produce something for me. AutoViz was able to produce. SweetViz was not able to work on that data because it was too large. So for the Detail, this is how you install it, and then I will leave it to you on how to run it and how to run it. I will leave that to you. So you go do that, your research on how to use the Detail package and how you use it for automated exploratory data analysis. We don't need to spoof feed you, okay? The last part also, I will leave it for you. Is just I just kept this here. I was just writing different functions on how you can, plot bar charts, histograms, and pie charts using Python. And I just wrote different functions here for you. Explore with this, get different data sets, and just play around it. Explore it. Tell us what you find. Tell us what you learn. Make mistakes. You know, making mistakes is part of learning, so be open to it. So I think that is it for me for today, and that is it for our exploratory data analysis. If you have any question, kindly ask. Dr. Austin, is there any question that we need to attend to? For me, I'm done with today's class. Thank you. I can see many people writing that they love the automation. The automation is very nice because you don't need to stress yourself writing several codes and it doesn't leave any stone unturned. So I really find that very effective. You should exploring that is good. I could see the text here by Dr. Austin on encountering missing values, what you need to do when you encounter missing values. That's very nice. Thank you, Dr. Austin, for having all this. I think at the end of the day, Dr. Austin, you're muted if you're talking. I think at the end of the day, some of these texts that we have here.
Yeah, sorry. I didn't know I was muted. So yeah, so I was saying that, yeah, it's nice. Yeah, because at some point, like, so it's good you start with the normal, I mean, so, or rather I would say it's good you know how to do, how to do these things from scratch,
From
like,
scratch, exactly.
like the kind of bottom to top approach. So
Exactly.
at some point, you don't want to, for me, I'm very lazy. So usually, I think at this point, I just want to do things very easy.
Yes.
Easily, because, yeah, so it makes no sense spending too much time on, trying to do these things when you can just feed in. But I think it's always nice you start to do it from scratch. Then at some point, you can, start using, it's also the same for libraries. In particular, when you start also to use inbuilt libraries, to perform tasks, like machine, like simple regression task. So, of course, you find libraries in sklearn or there are other Python libraries that can do a lot of things. But I think I would advise to start writing code from scratch, so you know how to implement it. Then after, then you can start working with, with libraries.
Exactly.
So,
exactly. I would always advise that too.
Yeah, because libraries usually might not really do everything you want to do. In particular, when you are, doing a novel approach, like, you want to formulate new methodology, and then there is a problem, because if you don't even know how to implement something that has been done, how can you implement something you want to improve on? So it's hard for you to implement. And also, this is also one of the reasons why I think in the 4th week, when we start, or yeah, probably next week, I can also see that we try to do a kind of bottom, like we can just do a simple linear regression algorithm, write it from scratch.
From scratch.
And we can just, yes. I think it makes sense. Yeah, it's just the normal. So, we try to, you feed forward things, and, you try to optimize, you try to use an objective function to, to ensure that you minimize the loss for the problem you're trying to solve.
All right, that's a good one there. That's a good concept there. And then at the end of the day, it's good to do this manually yourself. Get the manual how to do it. And for all those plots you're seeing the automation doing, think about it. For all those automation plots, how do you do it manually? You need to know it, because you may go for an interview one day.
Yeah, it's true. And additionally, there is something I would also, in due course, I would also introduce. It's called 9. So I find it very interesting. It's just, I think it's in the same class with the likes of Power BI. So KNIME is very good. You can also do, I mean, if you don't want to write code from scratch, like if you're not really the type that, if you're not really interested in writing too many codes like Python things, the KNIME is very good. I can send a link probably later.
No, you
or,
leave it to when we get to the Power BI class.
I
Leave it to
mean,
when we
it's
get
not Power BI. I think it's
no,
not
but leave
Power
it when
BI,
we get to that time, so at least
yeah.
we don't give out everything at the same time
Yeah,
and
so
bombard them with so much at the same time.
yeah, I mean, so just saying, because along the line also they want to work with tools that are already built for such. Imagine you can just import data into like softwares, then you can filter, things that you want to do without even writing any code. I mean, not all data science job requires heavy coding skills.
Exactly.
So to be frank,
Okay.
so why usually it's good to know how to use, like, to write basic program, is because even when you start using tools like nice user interface like Power BI or even Google Studio and the likes of these 9 that I mentioned, so that at the background you know that okay, there are things that are executing these things, and it makes a lot of sense.
Exactly.
Yeah. So thanks for today's class, and
Let me just address some of the questions I can see here. One,
yes.
Someone is asking about duplicates and what do you do to duplicate? Another person is asking about missing values. If you observe, I did say something here when we started this class that we cannot teach you everything that you need to learn. We are just trying to introduce you to what you need to know, give you some keys that would help you, but you need to be in charge of your learning. So for missing values, I saw that Dr. Austin talked about it here.
Yeah.
If you ask that question on the WhatsApp group, you guys should chat on the WhatsApp group, help yourselves. Get a link about missing values, drop it on the group. Let people, explore it, from the group. You develop a lesson about missing values yourself. Then we can give you 5 minutes next week. You can teach it to the class for 5-10 minutes. We just want you guys to do something. We don't want to spoon feed you on everything, sincerely. That will not be a good way to train you. Teaching you, giving you everything is not the best. So you go and find out if you have missing values. If you use the is null dot sum and you know that you have missing values, what do you do to them? Do you replace them using your mean, median, average, which is the same thing as the mean? Do you remove them from the data set? When do you remove them? When do you remove a column? If a column has so many missing values, do you remove it? When do you need to remove the column? When do you need to remove it as a row? How do you deal with it? Go and read that out. The same thing with duplicate. How do you find that a data set has a duplicate? We saw that one of the automated packages told us if it has duplicate, it can tell you that, oh, it has this number of duplicates. Now, if you found out that it has duplicate, how do you deal with it? Do you need to remove the duplicate? Do you need not to remove it? When do you remove it? When do you don't need to remove it? These are questions that you should explore on your own. And then chat on the WhatsApp group. Let us have that to be interactive. I saw that another person called Yusuf said something that he said, you're from Kenya. Oh, nice to have you, Bariako. So good to have you from Kenya. I lived in Kenya myself for some time, so I see Kenya as home. So good to have you around here. You're very much welcome. And you were saying that we should have remedial classes. Well, we don't need to do remedial classes because all the classes we've done so far, we've recorded them and we have the links, we have the videos on YouTube. So what you can do is that during the week, you can go watch those videos. If you don't have the link to those videos, just come on the WhatsApp group. Ensure that you get on the WhatsApp group, right? Ensure you get on the WhatsApp group. I'm going to put my email here, just in case if you're not on the WhatsApp group, message me and then we can send the link. I believe they've shared the link of the WhatsApp group here, right? Let me see. Yeah.
Yes, I did.
Yeah, you've shared it here. So join this WhatsApp group.
Please, can you copy it and paste it again?
Yeah, we'll just do that now. So join this WhatsApp group. And in the WhatsApp group, we'll be telling you, we will share the link of the videos. So you then go and watch those videos yourself so that you get up to where we are, so that you get yourself prepared for next week. Next week, we will have Dr. Austin taking us through modeling. So you don't want to miss that class. You surely don't want to miss that class. I will not miss the class myself because I believe there will be new things I'm going to learn from him. So I will be there present. So you don't need to miss it. Okay. All right, guys, we are 3 minutes over time and we always try to keep to time if you observe us very well. So we try to keep to time here. So thank you so much for coming in. We don't take this for granted. Thank you for doing your assignments. Thank you for putting in the effort. See you at the top where we all belong. All right. Take care. Have a great week.